We are now talking about the topic of probability, for which we are going to discuss the exclusive events and inclusive events, the conditional probability, and independent and dependent events. For this purpose, we will define these things as exclusive events. So, exclusive events means that when two events occur simultaneously, then they don't have anything common between these two events. Or in other words, that probability of A intersection B is equal to 0, then it is known as to be called exclusive events. Or in other words, probability of A union B is equal to probability of A plus probability of B. For example, part 1, odd and even numbers in throwing a dice. That means either odd numbers will appear on the dice or even number will appear in the dice. But there is nothing common between odd and even there. So this is known as to be called exclusive events. Second example, getting head and tail on tossing a coin. So when you throw a coin, either you will get head or you will get tail. But there is no event that can occur for head and tail. So that means what? Either head or the tail will appear. So it means the intersection between these two is equal to 0. Or right and the left on the turn of the vehicles. So either it can move towards the left or it can move towards the right. So there is no intersection between left and the right turn of. So mathematically, we call that thing that A union B is equal to probability of A plus probability of B. So in mathematics, we are going to define it like this part, that A, for example, n of A is 10 and n of B is 15 and n of A union B is equal to 25. So probability of A union B, that is equal to 25 over 25, and that is equal to 1. Probability of A is there equal to 10 over 25. Probability of B there is 15 over 25. So probability of A plus probability of B, that is equal to 10 over 25 plus 15 over 25, and that is equal to 1. So we can write it here that intersection between A and B is 0 there. So the event is known as to be called exclusive events. If probability of A union B is equal to probability of A plus probability of B, or probability of A intersection B, if it is equal to 0, then it is known as to be called exclusive events for this portion there. The other examples of the throwing a coin, either you will get head or you will get tail. So there is no intersection between head and tail there. So this is known as to be called exclusive events for this part. Now we are going to use the second example, that n of A is, let's say, 10, of B, let's say that is equal to 15, and n of A union B, let's say that is equal to 20. Now we know that probability of A intersection B, first we are going to calculate from this portion there. It is A it is B, it is 10, and this is 15. Let's say this is the portion which represents A intersection B, because the sum of these two is more than the universal set. So that means there is something common between A and B there. So let's say that is equal to X. Then A is 10, so it should be equal to 10 minus X. B is 15, so it should be equal to 15 minus X. So 10 minus X plus 15 minus X, and that should be equal to the universal set, and that is equal to 20. So minus X and plus X cancel. So 5 minus X is equal to 20, or X is equal to 5, where X represents A intersection B. So N of A intersection B is equal to 5. Because now they have a common portion between these two A and B, which is equal to 5. So we can write it here in this example that if probability of A union B is not equal to probability of A plus probability of B, then this event is known as to be called inclusive events. Or in simple words, if probability of A intersection B is not equal to 0, then that is known as to be called exclusive events for these two portions there. So these are the two different examples for inclusive and for the exclusive events for this portion there. Now we can have an example of this. When two events A and B occur simultaneously and their outcome is supposed to be calculated, and there's common thing between A and B there, or A intersection B is not equal to 0, then it is known as to be called inclusive events there. For example, getting a prime number and an even number in throwing a dice, that is an example for the inclusive events. Second example, sum of 6 with the odd number is on the dice, that is an exclusive event. Product is 4 and even number on the dice, that is an example for the inclusive events. Or in simple words, probability of A union B is not equal to probability of A plus probability of B, then it is known as to be called inclusive events. Or in simple words, probability of A intersection B, if it is not equal to 0, then it is also known as to be called inclusive events for this portion there. Now we will define first the conditional probability, and then we will define the independent and dependent events for the probability of A given B means, in simple words, that B event has already occurred, and from that occurred event you are finding the probability of A from that part. So this is known as to be called the conditional probability. So probability of A given B is equal to probability of A intersection B over probability of B there. So we will going to define this one by one with the example of that. The conditional probability probability of A given that B, and you write it like this: A given that B. This given that B means that this event has already occurred in that portion there. Suppose we take this example. It is A, it is B. Now, A given that B event has already occurred. From that occurred event, you are finding the probability of A, which is this part. So this means you are finding, in other words, this portion is going to indicate A intersection B. So we are finding the probability of A given B with the words of that probability of A intersection B, as this is part, divided by the B event has already occurred. So it is probability of B there. So if we take this previous example, this example 2, here A intersection B is equal to, number of elements are equal to 5. So this will be equal to 5 over the total elements, that is equal to 20, divided by probability of B, that is equal to 15 out of 20. So this 20 and 20 cancel out. So this is 5 over 15, or it is equal to 1 over 3. So this is known as to be called the conditional probability, when B event has already occurred, and from that occurred event you are finding the probability of A there. Now in the next part, if probability of A intersection B is equal to probability of A into probability of B, then it is known as to be called independent events. And if A probability of A intersection B is not equal to probability of A into probability of B, then it is known as to be called dependent events. Or in other words, probability of A given that B is equal to probability of A. That means what? B has no effect on the getting A there. So this is known as to be called independent property there. And if probability of A given that B is not equal to probability of A, that means what? A probability is affected by the probability of B. So it means it is known as to be called dependent events there. So this is the independent and dependent for the two events when A and B occur simultaneously. And this is the solution of that problem there. And we will now explain it further. Suppose example 1. There are 25 students in a class in which 15 takes accounting and 12 takes biology. Calculate the probability of those students who take accounting given that they take biology. Since accounting is A and biology, so it will be the probability of A given that B. So total student is 25, accounting is 15, biology is 12. So first, using this n of universal set is equal to n of A plus n of B minus n of A intersection B, which is equal to 25 is equal to 15 plus 12 minus n of A intersection B, where n of A intersection B is equal to 2. So this means that there are two students who are taking both subjects. So we are going to find out probability of A given that B. That B event has already occurred and there are 12 students in that. So probability of B is equal to 12 over 25. and probability of A intersection B is equal to 2. So 2 over 25. So if we cancel out, it will be 1 over 6 left there. So this is known as to be called the conditional probability. The second example is there that the probability that the test is difficult and Ahmed takes the test is 0.3. And the probability that the test is difficult is 0.7. Calculate the probability that he will pass the test. Let P is the event that will pass and D is the event that is difficult. So basically it is probability of P given that D, which is equal to probability of P intersection D over probability of D, which is equal to 0.3 over 0.7, and that is equal to 3 over 7. So this is the way that we are going to find out the conditional probability of these events. Similar is the third example there. You can work out for that Ahmed wins the given that the day is dry. So that means what? If W is the probability of winning and D is the probability of dry. So probability of winning over dry is equal to probability of winning intersection dry over probability of dry, which is equal to 0.04 over 0.6, which is equal to 1 over 15. Now independent and dependent events, we have already defined there that if probability of A intersection B is equal to probability of A into probability of B, then it is known as to be called independent events. And if probability of A given intersection B is equal to probability, not equal to probability of A into probability of B, then it is known as to be called dependent events. In a bag, there are 5 green and 6 red counters. 2 counters are drawn with replacement. The drawing of the second counter is not affected by the first counter, so it is known as to be called independent events. Example 2, a fair coin is tossed 2 times. Then the probability of second head or tail is not affected by the first draw, so it is known as to be called independent events. In a packet of 52 cards, 4 kings are drawn one by one with replacement. So whenever it is with replacement, it means the total number of the outcomes is remaining same. So when you draw the first king, its probability will be the 4 over 52. For the second, it will be again 4 over 52. For the third, it will be again 4 over 52. That means what? That drawing the king from that card pack of 52, it is not being affected. So it is known as to be called independent events. Dependent events means when the probability of second event is affected by the probability of the first event, then that is known as to be called dependent events. So probability of A intersection B is not equal to probability of A into probability of B, then it is known as to be called independent events, dependent events there. Example, in a bag, there are 5 green and 6 red counters. 2 counters are drawn without replacement. So whenever it is drawn without replacement, it means whenever you draw the first counter, the second counter is affected by the probability. So that is known as to be called dependent events. Second, cards and numbers are 1, 2, 3 up till 8. 2 cards are drawn by one without replacement. We know one thing, that whenever it is without replacement, the second card is affected by the probability of the first, which is not replaced. So that is known as to be called dependent events. So in other words means that if it is without replacement, then after drawing the first card, the second card is affected by the probability of the first. So that is why it is known as to be called the conditional probability for the dependent events to this part there. And then we are going to give us the overall summary for this probability. The probability of E is equal to favorable chances over total chances. Probability diagram, tree diagram, conditional probability. Probability of E is equal to 0, that means event cannot occur. Probability of E is equal to 1, that means event will certainly occur. Probability of E is going to lie between 0 and 1. The sum of the probabilities of A, if the probability of is A and not of A is A complement, then the probability of A plus probability of not A is equal to 1. Probability of A or B or both means probability of A union B, that is equal to probability of A plus probability of B minus probability of A intersection B. If A intersection B is equal to 0, then they are known as to be called exclusive events. And if A intersection B is not equal to 0, then it is known as to be called inclusive events. Then the conditional probability of A given B is equal to probability of A intersection B over probability of B. If probability of A given B is equal to probability of A, then it is known as to be called independent events. And if probability of A given B is not equal to probability of A, then the events are said to be dependent events. And in other words, if probability of A intersection B is not equal to probability of A into probability of B, then even then it is known as to be called dependent events. Some properties which are being used in this probability of A union B is equal to probability of A complement intersection B complement. B, probability of A union B whole complement is 1 minus probability of A union B, and if probability of only A, that means probability of A intersection B complement. So these are the tips which are being used in this topic of probability, and we are going to use one by one for the solution of this problem for probability later on.